Hi, and welcome back to Math Concepts. In this video we are going to look at some special tools that can help us solve counting problems. These are called factorials, permutations, and combinations. And they come into play for a lot of the counting problems. Not all of them, but these are tools that can be helpful in some of our counting problems. Okay, so there are special applications of the counting principles that are useful in some, but not all problems. And the key ideas for this video are know how to use these factorials, permutations, and combinations. So let's get right into things here. A baseball team has 9 players. How many batting orders are possible? So we can just go and tackle this problem with the counting principle that we talked about in some previous videos. We have 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoever's going to bat first, well, that could be any one of the 9 players on the team. The second batter has to be someone from the remaining 8, right? This first person can't go again. So we are counting without replacement. It has to be from the remaining 8, and then 7, and then 6, 5, 4, 3, 2, and finally, when you get down to the 9th spot, you've only got one person left to choose from, so you have one choice. Okay. Now you could do that computation kind of long way on the calculator, just entering in 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and get what you get. Okay, so 362,880. There is a special feature built into your calculator that can get this done much faster though. On this calculator, I go to the PRB menu, and it's right over there, that exclamation point. Okay, I need to enter the 9 first, so 9, and then go to PRB, and go to PRB, and then select the exclamation point. So 9 with an exclamation point, and it gets me my 362,880. Okay, so this has a special notation, 9 factorial. Okay, so in general, a factorial, and you can do it with any number, for example, 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay. So it is a shorthand for this type of counting principle argument that comes up a lot. Now, it can't be used in every problem, but it does work pretty often. Let's look at a similar but slightly different problem. A club has 20 members. In how many ways can they select president, vice president, secretary, and treasurer? Okay, so we have this club with 20 people in it, and we want to select the 4 officers. Well, using the counting principle, we have a task that can be broken up into 4 stages. Okay, if we're going to pick the president, we have 20 choices. Anybody in the club could be the president. Once that choice is made, when we're picking the vice president, we have to choose from the remaining 19 people. The same person can't both be the president and the vice president. That just doesn't work. And the secretary has to be chosen from the remaining 18, and then finally 17. Okay, so if I use my calculator to crunch those numbers, 20 times 19 times 18 times 17, I'm getting 116,280 ways to select these officers. Okay, now notice this is not a factorial. Okay. To do a factorial, you have to start with whatever number you're given. Like if we had 9 factorial, we start with 9, and then we count down all the way to 1. So this is not 20 factorial. However, there is a special function for it on your calculator. Okay, so we have 20 objects or people and 4 spots. Okay, so on my calculator, if I were to do that, here's what I'd have to do. I would once again be selecting something from the PRB menu. Notice that first choice there, NPR? That's your calculator's permutation function. So I need to enter the 20 first. I would do 20, and then go select NPR, and then 4. So we got 20 things in 4 spots, and equals. And once again, 116,280, just like we got before. So your calculator has a built-in feature for doing a computation like this, called the permutation button. So what I would recommend you look for on your calculator, look for NPR somewhere. Okay, it depends on the model of calculator that you're using as to where it is. If you have this model calculator, it would be accessed by first going to the PRB menu. And if you're going to use the permutation function on your calculator, you need to enter this, go get the permutation function, and then enter the second argument there. Okay, so you got 20 objects, or 20 people in this case, to fill 4 spots. It's a permutation of 20 things in 4 spots. Okay, one more example that I want to look at here. Okay, so just some notes there. On your calculator special features. Let's look at this situation. It's related, but still slightly different. Okay, so a pizzeria offers 7 different toppings. How many 2-topping pizzas are possible? One thing I want to note here. In this particular problem, order doesn't matter. In the previous problem, when we were selecting president, vice president, secretary, and treasurer, their order did matter because the different spots had different roles. But if you order a pizza that has sausage and green peppers on it, you can't complain that your pizza had green peppers and sausage. Right? A pizza with sausage and green peppers is the same as a pizza with green peppers and sausage. So the order of the toppings doesn't matter. So this is a slightly different type of counting, and it uses the combination feature. Okay, so we have 7 toppings to choose from. We're going to pick 2. Okay, so on my calculator, that's where the combination feature is. Once again, it's on the PRB menu. So I have to enter the 7 first, so 7 NCR 2. 7 things, choose 2 of them, order doesn't matter, so that's 21. Okay. Just some notes here. You might see some formulas for these things. So a permutation of n things in r spots is found by doing n factorial over n minus r factorial. Let's look at a quick example. If I had a permutation of 7 things in 3 spots, I could figure this out by doing 7 factorial divided by 4 factorial. Right? 7 minus 3 is 4. Okay? Now, if you look at the instructions here, you'll see, okay, that's 7 factorial, that's 4 factorial, and of course we know how fractions work. If we have the same thing top and bottom, we can cancel it out. So this would reduce to 7 times 6 times 5. Okay, which is equivalent to the formula or the procedure that I showed you before. And very similar, you can figure out combinations by doing this. The formula looks almost the same. You have n factorial, n minus r factorial, and there you have r factorial. Okay, so permutations and combinations. Okay, so factorials, permutations, and combinations only apply when we are counting without replacement, and factorials and permutations are for when order matters. Combinations are for when order doesn't matter.